Good morning, ladies and gentlemen. Today you are going to go inside a stellar black hole. Hence, put your belts on and enjoy the trip. The presentation is divided into 5 parts. First of all, I'm going to explain the life cycle of a star. Then, I will talk about the definition of a black hole. Furthermore, you will know what happens if a human being gets inside a black hole. Fourth of all, I'm going to calculate the necessary radius uh, that our sun must have to become a black hole, and ultimately, I present you a software that simulates the universe. Without further ado, let's start. All the stars you see at night were born in a stellar nebula, which is basically a cloud of dust, hydrogen, and other ionized gases. Due to the gravity, all is condensed and now you have a baby star. From here, the life of the star will depend on his mass. We have the small stars, for example our sun. Uh, when the stars burn all the hydrogen that they have, they will be a red giant, get bigger and then become in a planetary nebula. So I have an example. This is our sun. Currently, the current age is 4.6 billion years, and here is the Earth, and we are in the habitable zone, so we are alive. And in when this is the Sun as a red giant with an age of 12.5 billion years, so you can see here that the Earth is very close to this Sun, so the future habitable zone. Um, so we will be death. The end of those kinds of stars is to be a white dwarf. Um, so our sun will have the size of the Earth. And on the other hand, the stars, which mass is 5 or more times our sun, are considered as massive stars. Those stars, when burn all the hydrogen, will produce heavier materials such as hydrogen, such as carbon, gold, diamond, etc. In summary, all the elements of the periodic table. They explode in something that is called a supernova. So all those elements uh, fly in the universe, and I'm sorry, fly, yeah, fly in the universe, and from here new stars are born. So in a supernova, you have now a stellar nebula and starts other um, and start the cycle again. But if the star is from 30 to 70 solar masses, it will turn into a black hole. In the other case, it will be a neutron star. Uh, so a neutron star uh, have approximately 20 solar masses, and something that is special in those stars is that they have a strong magnetic field. So don't worry about it. Here I have a photo of a stellar nebula. So it's pretty beautiful for me. So what is a black hole? So the black hole is a finite region of space where the mass is so heavy that even light can escape of its gravitational field. Therefore, go inside and you will never return. Here is the first photo of of a black hole. It's located in the supergiant elliptical galaxy Messier 8087. If you want to flirt, if you want to flirt with a girl or a boy, this image is for you. So the heaviest objects in the universe. Here we have our sun, the neutron stars, a black hole, and my love for you. So it's cursi, but it works. And now let's talk about the spaghettification. So the spaghettification. If you go into a black hole, your feet are more attracted than your head. And the gravitational force is so enormous that your body will act like a spaghetti. Yes? So, of course you will die. Now we have the spatial radius. It's a simple formula that tells us what should be the radius of a body to become a black hole. So G represents the universal gravitational constant, and M represents the mass of the object, and C represents the speed of light. In this case, I will calculate the necessary radius of the sun to become a black hole. So mass of the sun is this. We put it into a calculator, and we have that the spatial radius is 3 kilometers. So if you are able to compact the sun into a ball of 3 kilometers, you have a black hole. Yeah. And now with the Earth, if you want to become the Earth a black hole, so you have to compact the Earth, so the same mass, into a marble, which have a diameter of 8.9 millimeters. So let's do something practical. Let's open my simulator. Give me some minutes. Okay, so this is called Universe Sandbox 2. It's a simulator, so you can travel, for example, in the solar system. You can manage the time. Yeah, you can manage the time, and you can go. What is the worst day over here? You can see what's happening to the Earth. So you are like God. Yes, because you can travel everywhere. I like this part. You can do a lot of simulation. For example, what would happen if two galaxies collapse? Yeah, here we had the simulation. So, as we are God, let's increase the time. Yeah, to focus. Yeah, we can see this kind of simulations. This is one of my favorite. But we can also see what would happen if, I don't know, the moon. No, the moon and the Earth collapses. It's very realistic, so we can see, for example, the mass, the radius, but it's pretty interesting that it let us see what would be the temperature. Let's see another simulations. We can do, for example, something interesting for you. Yeah, the supernova of our sun. This is the white dwarf. This is not the supernova. This is the planetary. Okay, I will run back. This is, oh my goodness. Yeah, the planetary nebula. So we can see now the white dwarf. A white dwarf seems like this. Yeah, this is very realistic. Yeah. Yeah. So you can see that the Earth will be bigger. Oh, something interesting. So we have the solar system. We can see the habitable zone. So the Earth is in the habitable zone. Yes, that is not too hot, but neither not too cold. Yes. Okay. Now I'm God. Yes, suppose that. And I have my sun. Yes, a little star. And I'm God. So we calculate that if our sun had a radius of 3, what would happen? Oh, that's not 3, it's approximately 2.8. So our sun now is a black hole. That's pretty interesting. So what would happen with the orbits? And the orbits will be the same because it has the mass. I think that's all for today. Thank you very much, and I invite you to use this simulator and to passionate for astronomy. That's all, my friends. Have a nice class.